and I will cheat. Hi, my name is James Jones. I'm a field-trained mechanical engineer and a machinist with 30 years of IT experience. And I want to illustrate how important manufacturing is to several large-scale problems that we face, and by extension, how even subtly changing manufacturing has far-reaching effects. We have too much mega-scale infrastructure in 4 specific areas. There are others, but these stand out, and the 4 are in agriculture, in resource extraction, apparently in slides as well, resource extraction, shipping, and solid waste. And by megascale, I mean that beyond any individual's capabilities, only large companies and very wealthy people are capable of building things at that scale. So in agriculture, the first major issue is commercial scale agriculture. Agriculture now occupies 40% of all habitable land area and is responsible for over 90% of all surface emissions of pollution. It impacts water quality, habitat loss, biodiversity loss, especially in the tropical countries. And it releases chemical pollution of several types. The second area is resource extraction. And slides. We're using resources faster than they can be found or replenished, and this impacts water, forests, fisheries, and has a huge economic dimension. Resources are the main driver behind military conflicts as well. And of course, shipping. Ships in international waters have minimal to no regulation on their emissions. The 15 largest container ships in the world emit more pollution than all 770 million terrestrial vehicles. There are over 5,000 ships on the international registries. It's a much larger problem than it's given. It's out of sight and out of mind. It's out in the ocean somewhere. So then the fourth major issue is solid waste. The United States produces in the vicinity of 250 million tons of solid waste annually. Of that, about 34% is recycled. And of the remainder, 9% is metals. At scrap prices, those metals are worth $40 billion. We throw away $40 billion worth of metals every year, and no effort is made to recover it because it's beyond our recycling system. The UN estimates that environmental systems worldwide absorb remediation with a value of about $2 trillion annually. And we're demanding more of these natural systems every year while reducing their capacity. So these are all really significant challenges. And if I stopped here, you'd assume it's all doom and gloom, it's over, we can all just go home and give up. But I'm very optimistic that we can address these problems because as we've developed these problems, we've also developed technology to help address them. So what do all these big problems have in common? And what they have in common is our consumption and distribution model. And I contend that if you look back to the beginning of the Industrial Revolution, production was done close to the market because transportation systems were poor. There's a strong relationship between transportation and a factory's capacity. Since the materials and fuel need to come in, finished goods need to go out, and transportation improves as our plant size increases as transportation improves. And I contend transportation is now a little too good, or at least it's overutilized. So, when a plant's capacity grows large enough, a structural dependence on access to several markets is created. Eventually, you get to the point where mega factories crank out hundreds of millions of devices. These get shipped all over the world. And then, at least until recently, with China, we shipped a lot of those recyclable goods back to China. So you have two trips around the world for the material, to get back to where demand is highest. And this is absurd. If you intend to recycle discarded materials, then shipping most materials is unnecessary. They're already near where they ended up. They're already near their market. And so they will tend to accumulate in proportion to their use in that market. Maybe you've heard this new thing, the internet. The internet, with it, a manufacturer can download any amount of descriptive data, no matter where it was generated, for a 10,000th of the cost of shipping anything anywhere. And I mean, it's mere pennies to get all that data downloaded. So the root of the problem is the model all these processes descend from, the linear economy. But there might be a way to address all of these issues at once by changing to a more reasonable model that recognizes how differently the world works today. Fortunately, the distribution model used before global transportation networks were pervasive is making a comeback: the circular economy. Most materials come from either recycling or local sources. Estimates are that in some cases, 75 to 90% of materials can come from recycling for products. In light of that, what if we reimagine the manufacturing process entirely, in essence, start over? And the wonderful thing about starting over is you can start over in the context that there's already a functional existing system in place, which means you don't give anything up, you simply migrate things over to a better method as needed. So, or as fast as you can. So you don't have to replace every capability in one step. Why not start with small, affordable machines? Then you can establish a system of manufacturing locally and grow that system over time. Given the low costs of small machines, they can change rapidly to meet new needs or expand their existing capabilities. And small benchtop scale machines are affordable to any business or a hackerspace or a small community. So this can be applied very universally across non-traditional channels. You don't have to just have it in factories. You could also have it in a community center, or you could have it in a hackerspace, and people could then get the things they need from a digital template, be able to download a pattern for an item, run that item out using recycled materials, and you're much closer then to having a sustainable solution. So a path to bigger and smaller machines, probably at double and half the scale, so everything will all fit together mechanically, is easy enough to add once you have affordable manufacturing in this way established. And so then let's talk open source for a minute. Open source is well established in software, and major inroads in open source hardware have emerged in the last 10 years. And so here are some examples of some open source projects. This is a very professional quality printer. Some large automakers have begun to use this to do rapid prototyping on their shop floor for assembly work. They pre-assemble stuff on a fixture, and then you can put it on the car, and everything goes a little quicker. They publish all of the plans for their machines open source on GitHub, so anybody can manufacture these. There are a lot of knockoffs of this printer available from China because the plans are open. Here's another open source project, FarmBot. This is for automated gardening. The plans are published open source, so if you want to go buy the materials, you can make it. They have a bill of material on their website, and you can build one of these things, and it will weed and water and even plant your seeds for you, and monitor your basils so that you can get all that pesto at the end of the year. This is an open source project that's more for social good. These are open source plastics recycling machines that the founder of this project wants to get into broad distribution to address the plastics litter problem, so that people anywhere can build these machines, recycle plastic. And then there's my project, which is called CubeSpawn, and it's a bunch of open source machines that fit into standard modules so that they can be plugged together in an array to do multiple steps in manufacturing. I've focused on this project for several years. And the idea is that these machines are put together as a mini factory. There's standardized technology so that they're relatively easy to build. They're very similar in how they function. And even people with relatively low technical skills will be able to use them. You'll go to the web interface, you'll pull down the thing you want to make, the machines will make it. So the other problem that you have is that local recycling is extremely challenging. It's hard to figure out how to process each one of the materials. So the same framework of cell-based machines lends itself well to putting together an integrated recycling system. With an integrated recycling system and manufacturing capability, you can take this group of machines, process materials from the waste stream, turn them into stock, and convert that stock into parts, pieces, or whatever else is needed. So open source allows you to set a standard so that anybody can manufacture one of these mechanical modules to fit in the machines to do any purpose. And one of the examples I like to use is, let's say I decide I'm going to use these machines to sort turnips. So I put together a vision system to recognize them, recognize blemishes on them, sort the turnips. Somebody else comes along and looks at that design and decides that they're going to sort tennis balls with it. They only have to make moderate changes to the way the process works to apply it to a different task. A third party could come in and turn it into an egg grading system. Because you have most of the pieces there, you just have to adjust them to the specifics of the process you want to apply it to. So open source lets you solve a problem once and then apply it many times. And the standard for the system holds it together so that I don't have to reinvent the entire system. I only have to modify the part that isn't relevant to my problem. So I mentioned 4 big problems at the start, and we'll leave agriculture for last. Using this approach, resource extraction is decreased by lessening dependence on new materials thanks to recycling. Shipping's decreased because you form local loops in the resources and things can be processed near where they're used instead of being shipped halfway around the planet. So waste is greatly reduced because it's now a resource. So you've addressed 3 of those huge problems with 1 innovation. The other part is that while local recycling is unlikely to eliminate all shipping, it could significantly reduce the volume, and the material cost gets reduced in an ever-decreasing spiral every time you recycle it. And agriculture, we'll get back to that. Agriculture can become more dense because, I forgot the game, didn't I? We'll skip over that. I guess we'll go back twice. Slides seem to be the problem. I didn't realize the resolution was so bad. This was put together in haste at the end. So a buddy of mine bought a greenhouse, and that greenhouse, what we're doing is we're building a lot of the components for it. And the idea is to make a replicable system so that not just we have this, but we have the design for the system, and then the system can be propagated to other people by using these machines to turn waste into the components that build it. So a greenhouse on a large foundation, it's going to have fish and mushrooms in the basement and then aquaponics in the top. And that way you get a synergistic feedback loop between carbon dioxide from the mushrooms, moisture from the fish for the mushrooms, and the carbon dioxide goes to the greenhouse, the fish produce manure, the manure goes into the water goes to the plants clean the water goes back to the fish. All that stuff happens as a feedback loop, and because it's below ground, we can use passive cooling so that temperature control is not a highly energy-intensive process. And, and then the idea is to take all the components in it and make templates for them so that the machines can make them, then other people can replicate the system elsewhere. And the game-like interface, some people in Wales have decided to build a game based on this. So you'll be able to play the game, and the idea is to evolve the game towards having a VR, AR interface so that you can do diagnostics on the internals of the machines without having to open them up. And there are other kinds of external projects. There's a project in the Philippines where some people are looking at building a self-sufficient village based around these concepts. And there's one of the universities in Michigan is considering adding this to their curricula. So, so the idea is that this is an open source project, so it's your project too. So anybody who feels like working on it, you should do so. You should apply it. I'd be happy to help. And changing from a physical to a digital distribution model means that all that shipping is eliminated, recycling is incentivized. There are a number of benefits across the board that bring us closer to a Star Trek type future where things can be produced on demand locally when they are needed from materials that are already there. And that is what I had to say about that. All right, thank you.